All right, guys, so this is to help you on pages 9 and 10 of the packet. Remember, the key here is that when we talked about ionic bonds before, we looked at charges. We looked at if it was like metal and non-metal, basically. And that's a simple version, like kind of you can get the right answer with that, but the electronegativity chart is the real way to get that answer. So you have this on your packet. What you don't have is this. You can find this on Classroom. You can also just copy down this if you can read my handwriting. So non-polar covalent is less than a 0.4 difference. Ionic is 1.8 or higher. And then polar covalent is anywhere in between. So I'll show you what I mean by a couple examples here. Calcium is right here, and it's a 1.0. And chlorine is right over here with a 3.0. So you can write it either way. The two numbers are 1.0 dash 3.0. Subtract them. So 3.0 minus 1.0, that gets you 2.0. Now you take that number and you figure out, is that less than 0.4? No. Is it more than 1.8? Yes. This is actually an ionic bond, so I would write ionic there. I'll show you another one. So H and O. So hydrogen is right here with 2.1. Dash oxygen here with 3.5. You did? Okay, hold on, Bubba. And if you subtract the difference, you're going to get 1.4. Okay, I look at that. That's in between 0.4 and 1.8, so that's going to be polar covalent. Okay, that's really all you're doing for this top section here, calculating the numbers and figuring out which range it's in. And then for these ones, just find the number. So I got you started on 1. So I found H and F for you. The difference between the two is 1.9. And that's actually the biggest of all of them, because what I want you to do on this one is put the most polar thing first. So I give that one number 1, because that's the most polar thing. Whatever's your next biggest number is going to get number 2. Next biggest number is number 3, etc. The meat and potatoes is down here. So PCl3. For this part, just look at one bond. So this one here, we're looking at the bond polarity. Just looking at one P and one Cl, not all 3 Cls. Over here, we're going to factor in those shapes. Okay, so we look up our values. P is 2.1. Cl is 3.0. The difference between the two of them is 0.9. So again, I look at my ranges, and that's going to be polar covalent. It's more than 0.4 and less than 1.8. So polar covalent. Now I need to draw it. So we're going to use our valence electrons for that. Again, not something you need to memorize. I wish you wouldn't. I wish you would just write it in. I've washed this enough times. It's starting to get a little messy. So phosphorus has 5 and Cl has 7. So 5 valence electrons and 7 valence electrons. So 1, 2, 3, 4, and 5. Chlorine has 1, 2, 3, 4, 5, 6, 7. I'm going to let it connect by a line just so it's a little cleaner. I also have a hint here. It says PCl3. That probably means I have 2 more chlorines as well. And I'm going to put them near where I have electrons on my bond with them. So 1, 2, 3, 4, 5, 6, 7. Let them connect. Now they both feel like they have 8 almost. And there was the 1 there. So 1, 2, 3, 4, 5, 6, 7. I'm going to let that connect too. Sorry, I'm trying to make it small for you guys. All right, so that's the drawing part. That's all I have to do for the drawing part. Now I need to find out if it's symmetrical both directions. What I mean by that is if I slice this like this, does that look symmetrical? And that does so far. If I slice it north and south, I see 1 chlorine on each side. It's basically symmetrical. But if I slice it like this, does that look symmetrical to you? To me, it does not. I have a chlorine down here, and I don't have a chlorine up here. So symmetrical, but not symmetrical. If either of those directions is asymmetrical, then that is what we write over here. Asymmetrical and and polar. So you're just copying what's up here, basically. Asymmetrical equals polar, asymmetrical polar, however you want to do that. I'll show you one more example, H2O. So first, we're doing the H and the O bond using the numbers here, 2.1. Yeah, babe. And 3.5.
Get my cars.
What do you mean?
My car.
Okay, sorry about that. So the difference between the two here, 1.4. So again, I look at the range. 1.4 is right here in polar covalent. So polar covalent there, polar covalent. Then I draw it out. Just give me like 2 minutes, 2 minutes. Then I draw it out. Oxygen has 6 valence electrons, and hydrogen has 1 valence electron. So oxygen has 1, 2, 3, 4, 5, and 6. And then hydrogen each has its 1. I'm going to put them near where they're found, so like that, near where there are electrons that could bond. So that's going to be basically my shape. Okay, so that would be correctly drawn. There's ways that I talked about in class about the incorrect ways to draw this. Now I'm going to do the same thing. I'm going to divide it north, south, and east, west. So if I divide it like that, that looks pretty symmetrical. But if I divide it like this, that does not look symmetrical. So this would be asymmetrical as well. Asymmetrical and polar. That is basically how you do pages 9 and 10. And hopefully this was helpful and not too distracting with everything and its mom that's happening at my house. Bye.